morning. Welcome to Tech Days. Welcome this room and also welcome in our overflow room, room 8. Good morning there too. Tech Days 2012 or Tech Days 2012. Thank you for being here. That's the first thing I want to say. It's a big investment from your time, so thank you for taking the time to focus on new learning, on readiness, on networking, and on connecting with other peers. Thank you for your own time, and thank you all also for managers putting the investment of taking you outside of work, outside of your projects. Thank you also to our partners. I would like to thank our platinum partners, our gold sponsors. Please take the time to go around in the expo. They have very interesting information for you. They have nice, interesting offers. So please also go talk to them in the breaks, which are long enough to allow you to really integrate with them. Thank you also to our silver partners. The partners are all present in this aisle, and then you also have the Microsoft booth in the bigger area. Now for Tech Days 2012. So why are you here? You're here probably to learn from experts. That's probably your first choice. You're also here, we hope, to connect and to network with your peers, with the other experts, with the speakers, international and national speakers. But what is the focus for this year, for 2012, for Tech Days? For us, it's in three main areas. So we are focusing on three main areas, and they evolve around one word: apps. Everything is around apps these days, right? So first of all, we have Metro, Windows 8 with Metro experiences, Metro applications coming later. We'll have a beta of Windows 8 or a consumer preview coming in 15 days. At the same time, there's also a lot of innovation in Visual Studio 11, in new tooling, ALM, and .NET 4.5. So how do you do locally, once Tech Days is over, there's one spot we want to send you to register for all local events and local information around these technologies. That's one focus on apps as well. The second area is around mobile and devices, mobile phone apps. And here again, there's a big focus at the conference, and at the same time, once you go back home, there's one location you can go to for the local touch on this information. And the last big area is, of course, the cloud. Well, you're going to see in just a few minutes, Scott will talk about the cloud and not going to Windows Azure. Now, how do you as a developer take your application to the cloud? How do you integrate with the cloud? How do you move applications from on-site to the cloud and hybrid applications? So you learn from the top, from the best, right in this session. And afterwards in the event, you also have other international speakers and local experts sharing new content, but also best practices and learnings from their applications. Again, we also have one location you can go to get started and to get the local input on events and more information that is locally relevant. Now, Tech Days 2012 it's a special edition. For the first time, we also have extra tracks. We also have today a dynamic CRM track. You can attend to as well if you want to pick some sessions. And tomorrow, for the first time, we also have an entrepreneur track. And this is interesting in the light of apps. We're talking about cloud apps, our phone apps, our Windows 8 apps. Well, maybe you're dreaming of becoming, starting up your own startup or becoming an entrepreneur yourself. Well, if you want to learn from some experts on trends and on startups, entrepreneurship, you can also pick and choose some of those sessions tomorrow. For 10 years of Tech Days, we We also want to make sure there's, next to the networking while you're here, learning from the experts, we also want to have some play. So it's not all work, also some play. What can you do? So today it's actually Valentine's Day, and probably your partners will have to miss you because you're coming late in at night because it's a long event. So you can do the Tour d'Amour, and then you go around to the Microsoft booths, and we have one Nokia Lumia to give away every day. At the same time, if you don't have a Windows Phone yet, you might want to get smoked by Windows Phone, so get your phone out and take the challenge. What is also very important at TechDays in the last few years, and today as well, this year, we have a very, very active community of Microsoft experts. We have branded them or grouped them in something called the Microsoft Experts Extended Team. They're community leaders, they're MVPs, they're local experts, so go visit them as well. They're here to help you solve problems as well. Some of them are speakers, and they hold tickets and vouchers to some great coffee. So if you want some latte, make sure you connect with them and connect to that community. And with that, I'm sure you're all waiting for one person. It's a great honor for the 10th anniversary as well of TechDays to welcome Scott Guthrie, Corporate Vice President, Windows Azure Platform. Good morning.
Good morning.
Thanks.
Well, thank you everyone for coming here this week, and looking forward to getting a chance to chat with all of you over the next couple of days. It's great to be back in Belgium, and I think it's a really exciting time for developers and for the Microsoft ecosystem in general. We got a lot of great products coming out later this year, and this morning I'm going to be talking about one of them that we've been working on and that I've been very involved in over the last 6 months, which is Windows Azure. Quick poll of hands, how many people here are using Windows Azure? Okay, a few people. Not too many, which is good for this morning, but hopefully when I come back here next year, we'll have even more hands. So what is Windows Azure? Well, even before I talk about what it is, I'm going to spend just a few minutes talking about why, and why I think the cloud and Windows Azure is kind of interesting. Fundamentally, I think the cloud is interesting for two reasons. And I think ultimately as developers, all of us are going to be interested in using the cloud over the next couple of years. And the two main reasons are it can save you time and money. It can enable you to deploy applications faster and with more reliability. And in this world of increasing devices and more client apps, having the cloud as a service that you can talk to is going to be really important. It also enables new scenarios, and hopefully you'll see over the rest of today a bunch of kind of places that you can use the cloud both to run your existing applications, but also kind of enable these new scenarios that just aren't possible today. Things like mobile enabling your workforce, so that you can talk back to existing enterprise assets over your phone or your tablet devices. Things like doing massive compute so you can analyze data. Things like storing terabytes or petabytes of data that you can data mine and get unique insights on. These are things that typically people don't do today because they either cost too much or setting up that infrastructure is too challenging, and with the cloud it's made really easy. So what is Windows Azure? So Windows Azure is Microsoft's cloud computing platform, and it's something we're investing pretty heavily in. It's something I've been involved in as part of my job for the last 7 months. Still very involved in .NET and VS as well, but I'm spending a lot of time also now working on Windows Azure. Windows Azure has a couple of core design tenets that I put up here on this slide. One is it's usage-based. This is kind of different than traditional server products where you pay money up front and then deploy them on your own hardware. Instead, with Windows Azure, you only pay for what you use. So there's no upfront costs, and you basically only pay per hour or per gigabyte of the amount of data that you consume or use within your application. And that makes it really cost effective for a bunch of workloads. It makes it really easy to get started. It's fully automated. One of the core things about cloud, and specifically Windows Azure, is that wherever possible, we try to kind of remove the need for anything manual to occur. And so all the operations are done in a completely automated way. And so you as a developer can use either an admin tool in order to log on and manage your servers, or you can just programmatically send REST calls into Windows Azure and do anything you want within your application, which allows you to kind of fully automate everything and make things really efficient. We provide a bunch of managed resources that you can program against. And I'll talk more about this throughout the morning. But you can think of these as kind of building block APIs or services that you can integrate into your application and take advantage of. The benefit is we do kind of all of the running of these services for you. And so we provide a very high service license agreement and reliability and backup and clustering and failover. And it basically gives you as a developer a bunch of cool capabilities that you can leverage within your application really easily. As I mentioned, we do provide kind of a service license agreement, or what we call SLA, which basically guarantees that your application will be available 99.95% of the time during a given month. And if for any reason it's not available, you get money back. So there's some enforcement behind that SLA. And it basically allows you to build applications knowing that they'll be available and that you can have high availability for your customers and users. Azure's elastic, which means that as you build your application, you can start off and use just say a single server, and then within minutes you can scale it out to use thousands of servers if need be. And when you're done, you could scale it back down to a few number of servers. And the benefit here is that means that you can start to build your applications and change the amount of usage or load that you throw against them to depend on your business. So if you have a large company, you might have applications that need a lot of capacity during the day. You can spin up a lot of servers to handle that. Overnight, you can actually trim the number of servers down to just be what you need minimally overnight to run the operation. And then when the morning starts again, you can spin up your servers again. Again, this helps save money and enables a bunch of interesting scenarios. And then lastly, as I mentioned, economics. We're really trying with Windows Azure to provide as efficient operation as possible. And so wherever possible, we're trying to kind of squeeze cost out of the system, which ultimately saves you money and lets you do a lot more. And the beauty about Azure is you can use the same .NET and Visual Studio skills that you use today with Windows Server and with SQL Server in the cloud as well. And so you're able to kind of leverage common code base in both places and write code that can run in a variety of different scenarios. This afternoon, I'm going to be doing a talk on ASP.NET MVC4. And the beauty is it just works in Azure in the same way that it works inside Windows Server. So one thing about the cloud environment is people often ask me, where is the cloud? How does it work and where is it physically living? Well, with Windows Azure, we have data centers that we run Azure across, scattered throughout the world. We have 2 in Europe, we have 2 in North America, and we have 2 in Asia right now. And we're expanding the number of data centers that we run continually every year, and you'll see more and more data centers show up around the world soon. Each of these data centers is kind of a hyper-efficient environment. We typically have tens of thousands or even hundreds of thousands of servers located in a single place. And we spend a lot of time focusing on how do we run those data centers with as low energy as possible. We use green energy wherever possible. So we use wind, we use solar power, we use hydroelectric dams in order to power many of these data centers. And the end result is not only something that's good for the environment, but it's also very cost effective from an energy perspective. A lot of people often ask, so what does a data center look like? So even before we get to code, what I thought we'd do is just quickly run through a simple video of what the inside of a data center looks like so you can get a sense. So as I mentioned, it's a kind of lights out operation. We don't have a lot of people running around. Instead, we have these containers that contain thousands of servers that are wired up and plugged in. We have very strong people that work at the data center that can carry these multi-ton servers around. And basically what we do is we wheel in these servers on these containers, plug in water, we plug in electricity, and then from that point on, it's a completely lights-out operation. So we never actually unplug the computers. Instead, we just wheel them in these racks. If a server goes bad, we keep it in the rack. If enough servers go bad in the container, we then at that point pull the container out, ship it off somewhere to be fixed, and then bring it back in the environment. And the end result is we can have a very few number of people that manage the data center and a very scalable, very cost-effective set of servers that we run within it. And the beauty is, because it's all automated, you as developers can do anything you want inside that data center and take full advantage of all those compute resources. And so what I thought I'd do is escape out of slides and actually drop into code and actually show you a little bit about how you can do this. So if you haven't been there before, you can go to the azure.com website or windowsazure.com website and learn a little bit more about Azure. You can sign up for it, and it provides everything you need in order to build apps with it. And so you can learn a little bit about kind of what the features are and what it provides. We have kind of a pricing tab so you can figure out how much everything's going to cost. One of the things we just did this morning was actually change the price of a few features. So for example, if you want to get what's called an extra small VM, which is your own isolated virtual machine, so your own OS that only your code's running on, and you want, say, a 100 megabyte database within SQL Azure, the price now is about 24 euros per month. And again, you can scale it up or scale it down depending on how much resources you want. We have a Develop tab where you can learn about how to program against Azure using a variety of different languages and SDKs. And we have kind of integrated samples throughout that site in terms of how to do things. And so you just click the one install button if you want to use .NET and Visual Studio. And then we have equivalent SDKs for other languages. And then we have also a free trial that you can sign up for that gives you 90 days of free compute resources and storage resources on Windows Azure. And everything I'm going to show here this morning you can do with the 90-day free trial if you want to go ahead and do the same sort of scenarios on yourself. So what I'm going to do here is get started by using the .NET SDK and build kind of hello world and show deploying it inside Windows Azure. And so if you just have Visual Studio already installed, you just click this button and you'll have everything you need in order to use Windows Azure. If you don't have any Visual Studio installed, click that button, and we'll also include the free Visual Web Developer Express edition of Visual Studio, which also supports Windows Azure. So once you have that installed, you can basically open up Visual Studio and just do File New Project. How many people here use ASP.NET? Cool, a lot of people. Me too. What I thought I'd do here is build Hello World using ASP.NET and then show deploying it inside Azure. And so I can start with a Web Forms app, I can start with an MVC app. All I need to do is just select the tab, give it a name. What would you like to call it? Goodbye World? Okay. Goodbye Cruel World. How's that? Yeah, okay. So we're gonna create our Goodbye Cruel World app. I'm in Waterloo, so there's an expression in England, he met his Waterloo, so I'm a little worried about this, but I'm hoping that won't apply to me today. But so we have our app here. It's just a standard ASP.NET app. I could run this app, and this is going to use the built-in web server that comes with Visual Studio, and here is our app running locally. And right now, this is just pure vanilla ASP.NET. There's no Azure at all in this experience. Let's go ahead and add Azure, though. And to do that, I want to be able to enable this app to deploy to Azure. And I'm going to do two things. One is let's change this text. What do you want to change the text to? Goodbye, cruel world. Love Belgium. There we go. And, and then the second thing we're going to do is I'm just going to wire up what's called an Azure deployment project to this ASP.NET project. And all you need to do is just right-click, and I just say Add Windows Azure Deployment Project. And this will add another project into my solution that allows me to store Windows Azure specific settings as well as kind of deployment configuration. And so, for example, if I wanted to, I could choose what size virtual machine I want to run this on. And so I'll talk a little bit more about this later, but for example, right now I'm just going to keep it with a small instance, which is a dedicated single core and about 2 gigs of RAM. If I wanted to, I could go up to an extra large instance, which would be 14 gigs of RAM and an 8-core server. And so you can basically choose, as you're building your app, what size you want. You can also choose how many instances you want. So in other words, how many servers do you want to run this on? I'm just going to say 2 servers to give me a little bit more availability. And I can choose some other configuration settings as well. Then I'm just going to go ahead and run it. This is going to do something slightly different than before. So before I was using the built-in web server that comes with Visual Studio. Instead now what I'm going to do is when I rerun this application, it's starting up at what's called the Windows Azure emulator, which is going to basically simulate the Azure environment in the cloud on my local dev machine. And so right now this is actually going to, if I go click here and bring up the Compute Emulator UI, one of the things you'll notice is it's actually simulating 2 servers running my application. And so I actually have 2 instances of this app because we said run this across 2 servers. And so if I go into that debug window, you can actually see some of the settings simulated across those 2 machines. So I would probably use more features if I was using Azure, but for right now, let's just stick with this simple app, and we'll just go ahead and deploy it into the cloud. So to deploy it, all I need to do is I'm just going to right-click and hit Publish. This will bring up what we call the Windows Azure deployment dialog. I'll start from scratch so you can see the whole experience. And so what you see here is this basically is a simple wizard that will walk me through connecting my dev machine with a Windows Azure account. I can just click Sign in to download. This will take me off to the Windows Azure website. We use any live ID. I'm just trying to show how open I am. The downside of doing so many demos is I have to have lots of accounts. And so what I do is I just log in, and I basically can save this what's called a configuration settings file. It's a one-time step. I don't have to do this on each deploy. Just the first time on my dev machine, I'll do this. And it's basically just downloaded a little XML file that I can then import into Visual Studio that contains my deployment settings. So there it is. And once I do that, it'll show me all of my Windows Azure subscriptions in this little dialog. And so I can choose which one I want if I have multiple that I want to deploy to. I'm going to click Next, and so we'll say, next option here is just name Cruel World, what I want to call this service when it's live on the web. And then I can choose what region or what data center region I want to deploy this app to. And so there's a Northern Europe option, as well as a West Europe option. So we're just going to choose the West Europe option. And then we'll see if, good news is no one's taken the Goodbye Cruel World domain name yet. So we're going to do that. I'm going to enable remote desktop so I can later debug this app easier. I'm just going to add a username and password that I can use for remote desktop. And this is basically going to upload into the cloud a certificate I can use so that I can basically stitch together my VM, and I can terminal server into it later and debug anything if anything goes wrong. And hopefully in a few seconds, once that cert is uploaded, that dialog will come back. And then, there we go. And then I'm ready to deploy. And so there's a few extra settings I can choose if I want to use, say, debug or release, as well as configuration settings. We're just going to stick with the defaults and hit Publish. And what this is going to do now is it's going to basically, we're going to walk through it in just a second, but it's going to basically package up my application and start the process of uploading it into the cloud. And if I pull up here my output window, you can see that process. And so we'll come back to this in just a second, but it's basically starting this process. It's connected to Azure. It's uploading my certificates. And this is now going to deploy this application across 2 servers in the West Europe data center region and expose it to the world as Goodbye Cruel World. And so we'll come back to it in just a second and hit it. While it's doing that, though, let's actually walk through behind the covers of what's happening within Azure. So as a developer here, I got Visual Studio. I've gone ahead and uploaded this application. So it's an MVC app that's packaged up. We call that a service package, and it can define not only a web server, or what we call a web role like we've built here. I could also have background servers that are doing background tasks that I could package up and include as part of this application as well. What Azure then do is once it gets this service package, is it basically opens it up, and then we'll look to try to figure out, okay, how many servers do I need to deploy this on? It'll then pick, in this case, 2 servers, because we said we want to run this across 2 separate VMs. It'll basically find 2 servers in the data center. It'll provision an operating system on it. And then it'll go ahead and deploy this MVC application into those 2 operating system environments. And as part of this, it'll set up IIS. It'll set all the appropriate certificates or SSL mappings if I've configured them. And once it's done with that, it will go ahead and configure a network load balancer to take that Goodbye Cruel World domain name and automatically distribute the load across those 2 servers that we configured that we wanted to run it at. And so the nice thing is it does this all automatically, and once it's complete, basically I can hit that web server or that web app from any type of device, whether it's a phone, PC, or tablet. Now the cool thing here is you can use the same .NET, same Visual Studio languages and tools that you already know, and we're investing super heavily in making that a great experience. We're also with Windows Azure making sure that you can use any other language that you want as well. And so we do have other SDKs available for different languages. So if you want to use Java, you can use Java. If you want to use PHP, you can use PHP. We've also recently added Node support. So if you're interested in using server-side JavaScript, you can do that as well. And over time, you'll see us kind of extend Azure to support other languages in addition. We want to basically make sure if you have existing code that you want to use, you can use that on Azure regardless of whatever language or tool you write it in. So let's walk through, actually, speaking of Node, how you could basically build your application using Node.js as well. Anyone here using Node.js? One person. Good. Well, so one of the things we do, if you are interested, we do have, in the same way we have a .NET Dev Center, we do have a Node Dev Center as well. And it's also kind of a one-click installer that you can use in order to actually get Node installed in your machine and actually be able to use Windows Azure with it. And so I already have it installed, and so I'm just going to go ahead and launch what's called a PowerShell window that we ship as part of that SDK, which is going to allow me to build Node applications with it. Let's just increase the font a little bit. Ooh, that is big. So I'm going to go ahead and create a new Azure service. What do you want to call it? Not all at once. How about Hello, Cruel World? So we'll go ahead and say, hello. What's that? New World? Okay, hello, New World. There we go. So basically, we have a set of PowerShell commands. So I just created what's called a service using hello, New World. I'm now going to say add Azure Node Web Role. I'm just going to call this the web front end. And this is going to go ahead and scaffold for me kind of a directory that has a couple different files in it. And so logically, you can think of this directory as kind of like a solution inside VS. And then the web front end is an example of like a project. And so I can have any number of these kind of node roles inside here that I can write code in. And so in this case here, I'm just going to go into this web front end directory. It's got a couple of files added to it by default as part of our scaffolding. This first one here is just sort of hello world in Node.js. And I'm just going to say hello Belgium. Hit save. And then if I want to, I can launch that same emulator that we used with Visual Studio, in this case here from the command line though. And this will, in just a second, oops, you know what, I might need to close that first. This will package up this application, and hopefully in just a second here, pop open my browser and allow me to run and access this application locally and test it out. Hopefully I will. Occasionally, the networking interferes, and I have a, which I think is what's happening right now. Let's try that one last time. My firewall rules are blocking the emulator for some reason from the command line. But otherwise, it would otherwise be accessed there, and I could basically run it. Oh, there we go. It did start. But my web server's running, that's why. So if I go ahead now and just hit this, what I should see is this will come back and it says hello Belgium, and I could say hello wonderful Belgium. Make a change, hit refresh, and see that change there as well. So this is an example of kind of simple vanilla Node.js in action, running inside the Azure emulator. So last thing I can then do if I want to deploy this application is I could basically set this up and get what's called a publishing profile. Just like I did inside Visual Studio, I can just type Azure get publishing profile. I could log in again and download the settings file. Since we already have downloaded, I'm just going to reuse that one. Oops. There we go. And then basically I can just go ahead and publish this service, and we'll call this Belgium node. And what have I done? If this was working, then I would set instance count. You know what? Someone already has taken the Belgium node app, apparently, which is odd. But, yeah. There we go. Sorry. This is going to go ahead now and kick off deployment and package this up into an application, upload it inside Azure, and repeat that exact same process that we created before. And deploy this application live on the web. So that, again, it's going to take just a few more minutes, and then when it's done, we'll be all set. So hopefully that just kind of walks through a little bit of kind of how you can build Hello World in both VS and Node, kick it off, get it deployed. In both cases here, I can run it across multiple servers and stand up any number of instances I want there. Any quick questions on that? Okay. Oh, there we go. We can go back into Visual Studio now. And just to show it's real, if you hit goodbye cruel world.cloudapp.net, this is that original app that we built using MVC. It's now deployed in the West Europe data center region of Azure. It's now running across 2 servers that anyone, including any of you in the audience, can go ahead and hit. It's basically scaled out with 99.95% reliability. So that's kind of Hello World end-to-end up and running. To manage this, I can also go to the Azure website, and I'm going to click the Sign In button. And then I can click the Manage link. And this is going to launch our admin portal for Windows Azure. And basically allow me to see the resources that are deployed and what applications I have deployed inside Azure. And so one of the things I should see is I'll see this app that we just built show up if I click this hosted service node now. So the Goodbye Cruel World is now deployed. And you can see that the Azure version of that is also going ahead and deploying shortly, and will show up in a little bit. If I click here and just hit connect, the other thing I can do is I can now terminal server into the machines that I deployed to. And so this is the virtual machine that I'm running this MVC3 app into. And when I log in here, this is accessing this application for the first time, so it's just going to set up my login profile. But a second later here, you can see this is my isolated virtual machine running one of the two virtual machines that I'm running my MVC3 app into. I have full admin access on the box. And so if I want to debug things locally or set anything up, I can. And again, the beauty here is I'm completely isolated from any other customer and running on that machine. And so I can keep an eye on all the things that are going on here. You can see the Node app starting up in just a second. Single way to manage everything. So that's kind of building Hello World. And as you saw, you can use any language, any tool, and especially if you're coming from a .NET or Visual Studio background, building these apps is really familiar, and you can use the same existing skills and tools you already know. Let's talk a little bit about some of the benefits, though, that you get with Windows Azure. So I kind of walked through deploying it. Let's talk about this process of how we deploy it. What are some of the benefits it gets with it? One of the things I mentioned at the beginning was this concept of kind of elastic computing that the cloud enables. And the idea there is it means that you can basically, as a developer or as an admin, choose how many resources you want to use and scale it up or scale it down at will, depending on what you want to do. So for example, in this case here, we built this application, both applications, and chose to use 2 servers as part of the deployment, and we specified that as developers. I could go into the admin tool, though, if I wanted to, and say, hey, the site's getting a lot of load. Let's scale it up to run on 6 servers instead. And when I do that, Azure will take that package that we already uploaded and use it to deploy across 4 more machines, and then bring them into the load balancer and add a traffic. And so now I have 3 times the capacity inside my app. If I want to increase it even further to say 92 machines, I could do that as well. And again, a couple more minutes, Azure will go ahead and finish deploying these apps across lots of machines. And basically now I have 92 servers running on the internet that are able to kind of handle the load of my application. And if after, say, today's event's over, I want to scale it back down, I can choose any number I want to scale it down to. And again, because I'm only paying for what I'm using, I don't have to pre-provision things, I don't have to prepay anything. I'm only paying the hourly rate of what my compute resources are. So if I run 100 servers for an hour, I'm only paying for 100 servers for that 1 hour. When I shut them down, I'm not paying anything extra. And that gives you a lot of flexibility as you're kind of building your apps. We often see with the cloud a couple of different what we call cloud patterns in terms of how people do usage. So for example, you might go to a period where you turn them on and then turn them off. For a lot of developers, when they're building their apps, they need the cloud capacity on. At the end of the day, if you're not going to work on the app for another 8 or 9 hours, you can just turn off your resources and then in the morning turn it back on. Again, the beauty is you're only paying for when you're using it, so you can save money. A lot of people in a startup environment or in a business that's growing want this ability where up front there's very low costs or no costs, but they know that as their business grows, they can keep adding servers, they can keep adding resources. Again, the cloud is great for this type of environment. Some businesses have kind of what's called unpredictable bursting. So let's say, for example, you get a press release or an article comes out about your company, and all of a sudden you see your traffic significantly increase. The great thing about the cloud is you know that you have kind of unlimited resources you can draw on in order to increase your capacity, and then you can turn it off if the traffic subsides. We also see a lot of people that have predictable bursting. So for example, let's say you do financing. At the end of the month, you need a lot of resources. At the beginning of the month, you don't need as much. Or say tax day, or if you know that you have a holiday sale, if you're in the retail market and you want to have a lot of resources available then, you can take advantage of kind of this ability to only pay for what you use regardless of these kind of 4 patterns, and you can save a lot of money with it. The other thing that's nice about the cloud is not just that you can increase and decrease resources at will, but the resources you use also provide a high level of availability and guarantees. And one of the challenges, kind of from a TCO perspective, that any shop, whether it's an enterprise or startup or anyone has to worry about, is hardware failures and kind of failures in the network and in the service delivery. And if you look at the downtime of most corporate applications, it's usually spent because of unexpected failures somewhere in the overall environment. And one of the things we try to do with Azure is design it so that you can actually recover from these types of failures, and that built into the system is enough redundancy to handle, kind of provide high availability. So with this app that we deployed, this Goodbye Cruel World, we've deployed it across 2 servers inside the West Europe data center. And so let's say, for example, we're running this application, and at some point, one of those servers goes down. There's a hardware failure, a disk goes bad, CPU blows up, a fan, a power supply, who knows. But let's say something happens with one of those servers. The nice thing about Azure is it'll automatically start sending all the traffic to the other server. So no one's going to get server unavailable error messages when they're visiting your website. We're also then automatically going to spin up a new server immediately in the background, deploy your application to it, and then once it's available, automatically add it back into the network rotation and start handling load for your site. And the beauty is you don't have to do anything in order to take advantage of this. The system automatically does it for you. You don't get called in the middle of the night. You don't have to worry about customers complaining. Instead, the overall environment can handle this type of failure, recover automatically, and in a lot of cases, you don't even know it happened unless you check the log. One thing I should mention is even when we deploy the application, not only do we deploy it across different physical servers, but we'll even deploy it across different racks, different network routers, different disks, so that even if the machine is fine, but let's say the network switch blows up, or if a power supply goes bad, you're still isolated in this type of way, and you get automatic redundancy built in for you. One of the things, as I mentioned at the beginning, that we offer with Windows Azure is a service license agreement, or what we call SLA. And so we guarantee that your compute resources are available 99.95% of the time, or again, you can ask for money back. And that's an SLA for the entire month, so it's not yearly, it's actually monthly. And again, that hopefully provides you with a very high guarantee in terms of your application availability, and ultimately can save your organization a lot of money in terms of wasted downtime. Other things that we provide in terms of Azure is the ability to do what we call smooth updates. So this is also kind of a challenge whenever you have a popular website or a popular application, which is how do you update the code without impacting the availability of the system. Oftentimes people will bring apps down on the weekend or at odd hours during the day to make sure that users are minimally impacted. You can do that, but still that's inconvenient for you, and there's probably still someone that wants to access it during that time window when you're updating the app. So one of the things we do with Windows Azure is built into the deployment mechanisms is the ability to kind of very easily roll forward your applications as well as roll them back if there's a problem. So for example, if you want to build V2 of your application, the developer just uses Visual Studio, republishes the application. By default, if you have 2 servers running, we design the system so that we'll actually upgrade the application across the servers, 1 server at a time. And we'll automatically take the machine out of network rotation, update the code, and then basically once it's complete, we'll take the second machine out of rotation, update the code, and then add it back into rotation. And the benefit there is your application is never down. You can also manually kind of walk through one at a time so you can verify the app's working. And again, provides you kind of with high availability and no customer impact. We also support the ability so that rather than upgrade your running machines, you can take advantage of kind of the elastic capability of the cloud so that you can actually just spin up 2 new servers that run the new version of your application. You're only paying, again, for the hours that they're running, so you don't have to spend much money to do it. We can give you a private URL to the new version of your app. You can test it out, and then if you're sure it's ready, you push a switch in the admin tool or you send a REST command to us, and we can automatically switch all the new traffic to the new servers. We can keep the old servers around for you however long you want. So if you have a problem, you can push the panic button and switch back to the old version. But this gives you a chance that you can actually keep the old and the new app simultaneously going, and then control which customers go to which servers, and you can basically stage your deployment however you want. All these things, again, are just built into the environment and basically give you a lot of power and flexibility in order to run your applications. Key thing that we're trying to do with all these things that hopefully you pick up on is allow you as developers to kind of focus on your apps and not have to worry about the infrastructure. And that's kind of part of the power of the cloud, is that it provides you with a lot of infrastructure resources without you having to kind of mess around or twiddle with a lot of the details. And the end result, hopefully, is a lot of developer productivity, but also it means that you can take advantage of very high availability guarantees, and your application scales out and runs even better. In addition to kind of providing kind of the basic deployment capabilities I just walked through, we also have a bunch of capabilities that we call kind of building block services that you can use within your application to program against. And this is just an example of a couple of those types of services. So for example, we have storage services where you can go ahead and save and retrieve things from the cloud and store them very reliably. We have messaging capabilities, so if you want to fire queues or publish and subscribe messages across your application, you can do that. We've got security and identity, we've got caching, content delivery network, and a bunch of other networking capabilities. And the beauty about all these things is they're really easy to program against, and you can optionally integrate them within your application. I'm just going to spend a little bit of time walking through a few of these. First one here we'll talk about is storage. With Windows Azure, we provide a variety of different ways that you can store data. And this is just a few examples of a few of them here. The first one I'll talk about is called blob storage. Basically, you can think of it as kind of a highly available file system in the cloud. So say, for example, I have those two web servers or two web roles that I deployed my MVC app to. Let's say I want to store images and allow users to upload images across both of them. I can't really store those images on the local disk of each of the web servers because I have two of them, and I want to make sure that if I get really busy, I can scale that out across 10, 20, or 100 servers. And so instead I need some kind of file system that's going to be available that both of them can program to. And that's really what blob storage, one of the benefits that blob storage gives you. And you can basically program against it from your .NET code or any kind of REST API. You can also optionally, anything you store in the blob storage, you can optionally expose it to the public web as well. Or you can just keep it private. But the benefit here is if you want to, you can upload an image and then expose the URL directly within your application, and Azure can automatically serve that file to any user that requests it. And then you can optionally securely lock it down if you only want to grant access to a subset of users. So let's go ahead and see some demos of this in action. So using blob storage is really easy. If you want to know how much it's actually going to cost, you can just go to azure.com and just click on the pricing tab. You can either see it right here, or if you want to do a kind of a full pricing calculator, you can do that as well. So we'll just switch to euros. And I can basically, if I want petabytes of storage, that's a lot. But if I want, say, 175 gigabytes of blob storage that has 99.9% availability and scaled out across multiple servers and automatically backed up, that's how much I basically could pay for it. And the prices kind of go down as you store more usage. And in general, it's one of the cheapest kind of ways to store data reliably anywhere in the cloud. So if I want to program against it, or once I want to use it, let's actually just see it in action. So what I could do is I basically go into my admin tool, and we have kind of a way you can create what's called a storage account. And so just click on storage accounts. So I basically just create a new storage account. I can give it whatever name I want to in order to make it available. And then once I have one, it'll actually, I have an access key I can just copy and paste and then use within my code. I could use a variety of tools with it. So this is a simple tool called Cloud Explorer that someone's created that you can download for free on the web. And so, for example, I'm using this in a couple different places for myself. So, for example, I use this to store my backups of my files for things like demos. I also If I wanted to, I have a simple hello TechDays account that I created earlier. If I wanted to, I could go ahead and go to pictures. And if I want to upload a picture, I can just copy and paste it. And this little tool will automatically go ahead and upload this image into my blob storage account inside Windows Azure. And if I go ahead and hit properties, that's the URL for it. And I can map a friendly kind of vanity URL, any custom domain name I want. And this is now being served out of my storage account inside Windows Azure. So pretty easy to go ahead and upload files and then optionally make them publicly accessible if I want to. If I want to lock this down, I could also go ahead and, from a permissions perspective, restrict it only to a certain subset of users. So this is kind of a simple utility. I can upload anything I want in it. Let's go ahead and do something a little bit more interesting now, which is, I'm going to open up a project I've built just to show kind of as a developer what I can also do against it. So this is a simple Hello World app. It's an MVC app. Let me just run it and then we'll walk through the code. And this is just going to go against my storage account in the cloud and allow me to view images I've already uploaded as well as upload new files and store them reliably within Azure. And so once this thing opens up, oh, you know what? We're already running this with another project. Let me close that down. So, oops, let me close and restart this project. So I'm going to go ahead here and open up the emulator. And it's the benefit of having too many projects open at the same time, is they're all competing on the same IP address port. So I'm just going to open up this project. And hopefully, if the emulator is not working now, there we go. I'll show off kind of a simple, this is going to go off to the public Windows Azure cloud. This is just looked at that same storage account that we were using that tool against. And you can see that koala bear is there. If I want to, I could go and upload another picture directly within this app, to a jellyfish. Hit upload. This is going to program against Windows Azure. It's going to upload that file. You'll notice it now shows up inside the tool. If I go back to this tool here and just hit refresh, you'll notice the koala has been uploaded there as well. So a simple example of using a GUI tool to manage my storage, and then also how I could program against it within an ASP.NET app. This is what the code looks like. So it's pretty simple. Basically, I have two controller actions, one called index, one called save. And the index one here basically is just retrieving this blob container from my Windows Azure account. This is sort of the code with the key that I program against to access it. And then basically my save code here is basically just uploading the file that was uploaded through the web app into blob storage, and then redisplaying the list of images. So pretty simple, couple lines of code, standard .NET. With that, I'm able now to actually store any amount of storage I want within my front end, and I can scale out my web roles and I can scale out my storage, and I only pay for what I use. So if I wanted to, I could store petabytes of images, and I could run this app across hundreds or even thousands of web servers, and I wouldn't have any single point of bottleneck anywhere within the system. One other thing that we do with all of our storage is whenever we upload anything on disk, we store it in 3 locations. So we store it on 3 physical locations on 3 different servers. And that way, if a server goes down, we can automatically have availability still provided for you. We also now, by default, take anything that's uploaded, and in the background, we'll actually copy it to another data center in that same geolocation. So that even in the event that a data center disappears or there's a natural disaster, you can actually switch over to another data center in order to pick up the availability. So my picture of my koala bear and my jellyfish will be in Northern Europe within the next 10 minutes on 3 other locations there. So again, if for some reason Western Europe disappeared, then my koala bear is safe. Generally, if that happened, that would probably be the least of your worries. But for businesses that want to make sure they have high availability, again, that's one of the benefits that the cloud provides. Yeah. Yeah, good question. So the question is, so you've uploaded this, the question was, if you upload this once or twice, so for example, within my web app, what actually happened here? Did it upload it and then upload it again, or how did that work? So that's a very good question. So the might have been a little confusing from this demo maybe. Basically, you only have to upload the image once, and so this wasn't saving anything to the local web server. All I was doing was basically, from within the browser, posting this image to the web server, and then the web server writes to blob storage. Because the web server, when it's deployed inside Windows Azure, is running in the same location as the blob storage, you're not paying any extra bandwidth costs. It basically, the web server can talk directly to storage using local access, or not local access, but a very high-speed network link. So it's very fast, even if you want to upload hundreds or thousands of megabytes of data. Other thing about Windows Azure it's worth calling out is that you never pay for any bandwidth charges when you're uploading data. So running this application and uploading even a couple megabyte images, you're actually not having to pay any incoming bandwidth charges. Those are always free. You do pay for outgoing bandwidth charges. An app typically like this, you'd typically obviously resize the image and you wouldn't be sending down megabytes per image. But the end result here is that you're only uploading this thing once. You're not paying for any of the bandwidth on the upload, and it should be really high speed and very available. So it's a simple example of blob storage, and the nice thing about blob storage is you can stick pretty much anything you want within it. Oftentimes, though, you want to have more complex data, and you want to be able to do querying or access it in a relational way. We have a service that we also provide with Azure we call SQL Azure. This is basically a relational SQL Server engine that we run inside the cloud for you. It provides the same programming model experience that you get with SQL Server on premise. So you can use ADO.NET, you can use the Entity Framework, you can use Link to SQL, you can basically use any standard programming model against it. And it's a fully managed service. And the benefit here is it means that you're not having to do backups of your database, you're not having to manually tune indexes. Instead, the service kind of monitors your usage, it self-tunes the database for you, and it provides high availability as well. So in other words, when you actually read and write to SQL Azure, in the same way that blob storage saves it to 3 locations, SQL Azure also saves your data on 3 clustered servers, so that if a server goes down or a disk goes down, your database is still highly available. And it basically provides all that out of the box for you. We just actually, this morning, announced some price changes on Windows Azure. And so if you go to the Azure website and check the pricing, you'll find that SQL Azure costs on average, I think, went down this morning by about 45%. And we also now have a new pricing option for SQL Azure. I think it starts at €3. That gives you kind of 100 megabyte of SQL Azure storage. And again, that 100 megabytes is not just providing SQL storage, but it's actually providing 3 SQL servers so that your data is always highly available. Again, you only pay for the amount of data you use. We also then provide something called table storage, which provides you with a non-relational table services, so a key value pair. You can actually store table storage to hundreds of terabytes of data, and again, provides high availability that you can program against it. Again, all those things are just built in to the service and are great APIs you can just use. How many people here are using messaging, like message queues or some kind of mechanism? Okay, a couple people are. For people that aren't, one of the things that messages and message queuing gives you is the ability to kind of avoid what we call tightly coupled apps, which often have kind of fragility when things go down. So for example, let's say you have a simple application where you have a storefront for like a retail website that's talking to some kind of back-end shipping or tracking service, which is then actually coordinating with the actual distribution of your products when someone buys something. And so when an order comes in, you send a message, or call a shipping service in a synchronous way, and then send it off. So this would be an example of what we call tightly coupled service. There's no queue involved. The downside with that is if for some reason your drivers become unavailable, there's weather problems or something like that, if it's very tightly coupled and your service in the back end goes offline, you can end up causing your website to go down as well, or people can't place orders, and that has big business impact. And that's kind of a downside of a kind of a tightly coupled architecture. One of the things that kind of, from a design perspective, people often look for now is kind of a loosely coupled architecture. So instead of, for example, having your web server talk directly to a back-end service, you instead talk to it through what's called a queue. And so I could have an order queue so that when someone placed an order on the website, instead of talking directly to the back-end service, instead I could write to a queue, and then I could have a back-end shipping service pull orders off the queue and then process them in the background. And the benefit there is if for some reason that service goes down, I can still, from the front end, fire orders into that queue. And even though they're not being processed, I can basically, as soon as that shipping service comes back online, I know that those messages are preserved and it can start processing the messages. And so that way now I've basically decoupled my front end and my back end and improves the overall reliability significantly. The other benefit of this kind of approach is that it gives me a lot of scaling benefits. So if I have lots of front ends, I can basically have them all be sending orders into an order queue, and then I can have any number of back-end processors actually take those orders and process them. And the benefit here is I can basically choose to scale up or scale down any part of my application depending on the actual usage of it, and I have a very kind of elastic architecture that'll scale well. One of the things we have built into Windows Azure is queuing technology. So you can basically integrate queues really easily within your application and use it for both availability as well as scale out purposes. And so I'm going to do a simple demo here where I'm going to invite people from the audience. If you have a laptop or a mobile device, I might need your help. So power those up and connect to Wi-Fi. And basically what I'm going to do is allow you to go to a website, you post a message to me, we're going to post it into a queue. And then I'm going to go ahead and route that message and process it on my own local laptop. And we'll just spit out the message. And this is all decoupled and kind of provide with high availability in mind. So let's try this in action. So open up. Simple project here. This is just a ASP.NET web app. Let me just run it here. And so this is running in Azure right now. And I can just say, hello, Belgium. And this is going to go ahead and fire a message into the queue. And so it's basically a simple message here. And if you want to send your own messages, you can go to sbdemo.cloudapp.net. Put that as the URL, so if you want to try that out. And basically the way I've implemented this inside my MVC app is pretty simple. I just have a controller here, and all the controller is doing is displaying a page, and then basically has a simple send message command action that when someone posts, it just connects to the queue, and then just fires a message into it with the text that was posted. Then I'm going to have a backend, which is a simple command line console app, so just simple program.cs file. And all this is doing is connecting to that same queue, but this is going to be running on my local laptop. And it's just going to retrieve the messages in an infinite loop, and then basically just output the body on the command line. So if I go ahead and connect now, it's connecting to the cloud. There you go. And so you can, there we go. People in the audience are actually, oh, there we go. Yeah, thanks. And so, hello, everyone. If I post it here, it's posting into the cloud. And There we go, and somewhere hello everyone should be showing up. And so you basically, there it is. And so basically you can see here we have an interactive demo all running. And the beauty here is I can scale out any number of front-end servers I want. I could also, if I had a whole bunch more machines in the back end, I could also be connecting, processing those as well. And this is all, this app here is running on my local laptop, but the web role as well as the queue is running inside the West Europe data center. So, cool. Very scary stuff. Well, Sandra, someone loves you. So, cool. You never know quite what you're going to get when you do that demo. That's sort of simple example of queues in action. Other things you can do that queues kind of enable, and more specifically messaging in general enables, is kind of this notion of kind of what we call hybrid applications. And so this was actually kind of an interesting example in that I had some code running on my local laptop or on-premise, and then some code running inside the cloud. And an important thing to keep in mind about the cloud, and specifically Windows Azure, is it's not all or nothing. In fact, for most corporate environments and most enterprise environments, you're going to typically see most cloud apps will have a hybrid scenario of some code running locally and some running in the cloud. And one of the benefits, obviously, with .NET and Visual Studio is that you can use them to program both sides of that equation. You can also use them to program the client side, obviously, with Windows 8 and Windows Phone and ASP.NET for the browser. And being able to stitch all of those together ends up being really powerful. And so, a typical environment we often see is that someone says, hey, I have a database that that's really large, or we've already paid for the hardware, or I don't really trust to upload my data into another environment, so I can't move it from my on-premise. But let's say, for example, I want to build a mobile phone app that allows my employees, when they're on the road, to look up data or to see current status. How can I stitch that together with the cloud? And so, as a simple example here, I might want to have some code running inside Azure, whether that's to a front end or whether that's to process the data, and then I want to keep my database locked down on premise in my existing environment. And this database could be SQL, it could be Oracle, it could be a mainframe. What you can do here is, in the same way that we use messaging, there's also a feature called the Service Bus Relay that I can also use in order to actually bridge the cloud in my on-premise environment. And so in this case here, I'm going to build a phone app or a tablet app. It's going to access an ASP.NET app running inside Azure. And instead of using a service bus queue, it's instead going to use what's called the relay service to call back to a WCF service that's going to run on my local laptop. And this WCF service is then going to go access a SQL database or SQL Express database running on my machine and return data to my web role running inside the cloud. And I'm going to do this all synchronously. So whereas with the queue, I was loosely coupled. In this case here, I want the phone app to be able to retrieve the data from the database all in one operation and send back HTML to the phone app directly. So let's try this out. So we close this project. We'll open a new project. And so this is the, let's open up the front end as well. So I basically have two projects here. One is the front end, one is the back end. And so here's the front end. The front end is just an ASP.NET app. So it's again an MVC app. And I've got customer controllers. And basically this is just doing pretty simple CRUD operations on top of a database I'm calling. And what's interesting about this though is it's calling a customer contract service implemented in WCF. So this is what the contract looks like in WCF. It has a get customers and a get customer by ID method on it that you can call. And then my web app is just talking against this. What I've then done is I'm using the Service Bus Relay to publish a WCF endpoint inside Azure. And then I'm implementing that contract on a local app that's going to run on my laptop here. And so you can see here, it's just a command line console app. It's implementing that same iCustomer contract service. And these are the two methods, get customers and get customer by ID, that it's going to implement. And what's nice is I'm then setting up a TCP channel using WCF between my laptop and the service bus running inside Windows Azure. And now anytime that web role tries to access the service, it will be routed to my laptop, and I can serve out this request directly from my laptop machine. So we're just going to run this app. And what I should see here is this will connect to the service bus inside Azure. There it is. It's now connected. So now I have a TCP connection from my local laptop to an endpoint exposed with WCF inside the service bus. It's a private endpoint, so only my application inside Azure can access it. So you should not be able to directly access this endpoint and send me messages. But now I can go ahead and build a front end in ASP.NET that securely talks to it. And what I'll see here is now when I'm using this front end inside Azure, so this is running inside Azure, I'm tunneling back to my laptop to retrieve those database requests and populate the screen on the page. And if I go ahead and hit this even with, let's say, a phone emulator, here. So this is basically running on a simple iPhone emulator. And when I'm doing this, every time I'm interacting, I'm actually accessing my laptop to retrieve the data on premise and populate there. So no data is actually ever being stored inside Windows Azure. The data all lives inside my existing database in my on-premise environment. And instead, I'm using Windows Azure to effectively provide a mobile front end that any phone or any tablet or any of my customers out there could use to basically get access to the data we already have. The beauty here is I'm only having to pay for the 2 web roles or 1 web role that I'm running this app on. All my data is stored on premise. I can lock down my data so that only my employees can see it. And rather than opening up my network entirely, the only thing that's being exposed from my local network is this iCustomer contract with these 2 operations on it. So I can completely lock down what happens. I get to control my data entirely, but I'm now able to kind of mobile enable my workers. And in the same way I can do it with an iOS device, obviously I could have a Windows 8 slate, I could have a Windows phone, I could have an Android, I could have any number of devices I want to, and I can use this as kind of an easy way to expose it. In my MVC4 talk this afternoon, I'll talk a little about one of the themes of MVC4 is enabling mobile web apps. And so we now have actually built into MVC4 new project templates for allow you to building jQuery mobile apps. So I could basically build this type of front end really easily. And with Azure, I can connect up the back end and reach any number of customers. And again, the beauty here is I only pay for what I'm using. And so in this case here, if you go to azure.com, and I want to price out how much would all this cost, again, I go to the pricing calculator to see how much everything's going to cost. For the service bus relay, the way it works is kind of nice. You basically pay by what's called relay hours. So let's say, for example, I wanted to have 1 web role talk to my back end on premise. The one downside is I only need 750 hours, but I can't slide it that small. But if I got 3,600 hours, which would be enough for about 5 servers to talk on premise, that would cost me €2.55 per month. So it's pretty cheap in order to wire up that demo I just showed. And again, you're only paying for what you're using. And so if at any point you want to scale up or scale down, it's really easy to do that. So those are some examples of some of the building blocks that you can build on with Azure. There's many, many more. And what you're going to see us do over the next couple of months is expand those number of services pretty dramatically and provide you with even more APIs and services you can use in the cloud to build your apps. And the end result is hopefully a lot of developer productivity because we provide a lot of those hooks for you by default, but also kind of service license agreements so that you know that when you talk to those services, you have high availability and that you can depend on them always being up. To kind of learn more about these types of services in Azure in general, one thing to go check out if you go to that website, again, is the Develop tab. On the Develop tab, there's all these dev centers, so pick your language. We have a bunch of tutorials, so if you want to learn how do I use ASP.NET with SQL Azure, there's kind of a step-by-step guide that walks you through exactly what you do. We also, on the left-hand side, have a bunch of how-to guides. So if you want to learn how to use the blob service that we saw earlier, You can click on that, discusses it kind of from a conceptual and setup perspective, and then we'll actually show you kind of code you copy and paste in order to do common operations, and makes it really easy to get started and try things out. In addition to kind of talking about our dev services, we also have what we call common tasks. So if you want to see how do I wire up a custom domain name, DNS service, it walks you through there. If you're an environment, you want to set up what's called continuous delivery, so that you have, for example, a build server that automatically uploads your project into a testing slot or into production. We have a guide that shows you how to set up TFS to do that, and in a completely automated way. And over time, you're going to basically see us build out these tutorials even more, and provide lots more capabilities. All the demos I showed as part of this talk, you can also get from our training kit, and so you can actually download the code, look at it, and run it locally. Other thing I should mention is all the APIs that I showed here, they're really easy to get within Visual Studio. You can use NuGet, and you can just say install package, for example, Service Bus, or install package Azure Storage, and we'll download those libraries and add them into your existing projects. We're also releasing the source code for all these libraries on GitHub. And so you can actually go to our GitHub account, and so if you want to download the source for any of these libraries, you can do that. You can also make contributions if you want. So if you find a bug and you want to fix it, you can fix it, send a pull request to us, and we can actually integrate into the source. So we do provide SDKs that have kind of fully tested, certified libraries you can download, but you can also pick up daily bits or even hourly bits from our GitHub account, which is actually where we're doing our live development, and can iterate there as well. And we have GitHub accounts for different languages, so depending on your language, you can go ahead and get access to it. We provide both MSDN forums. We also now support Stack Overflow as kind of one of our default forum mechanisms, and so you can also get questions answered there. And we have a really active community both on Stack Overflow and MSDN that you can take advantage of. And everything you need in order to get started, whether it's the developer documentation, the free trial, pricing information, you can go to windowsazure.com, and in a few minutes, in under 2 minutes, you can be signed up. And all the demos I showed here today are on released shipping bits. And so you can go ahead, download the tools, start building apps, deploying them into Azure immediately. We think there's a lot of power and a lot of capabilities it provides. Over the next couple of months, you're going to see us roll out even more capabilities and more power. Expect to see Azure being kind of a pretty core thing that we're going to be integrating into our server environment. And I think you're going to see, especially as a .NET VS developer, a lot of really exciting things start to show up in the months ahead. Last thing I'll just mention, how many people here are MSDN customers? Great. Turns out you already have Azure included as part of your MSDN subscription. Something a lot of people don't know. But basically, every MSDN customer actually gets free Azure hours included as part of your subscription. So if you go to Azure and as part of the free trial, you sign up using your MSDN account, you actually get free hours. So if you're an MSDN professional customer, you get, I think, 375 free hours a month, which is enough to run one full-time extra small instance 24 hours a day. If you're a premium customer, you get 750 hours per month per developer, which is enough to run a small instance 24 hours a day, 365 days a year. And if you're an ultimate customer, you get, I think, 1,500 hours a month, which is enough to run 2 small instances 365 days a year, 24 hours. You don't have to pay extra for it. They're just included as part of your subscription. And each one of your developers on your team, if they each have an MSDN account, they each get those hours. So if you have a 10-person team, all your development and testing, you might find, has actually already been paid for on Azure. And you can sign up and use those hours immediately as part of your account. So that's something to know that's available. If you're a startup, we also have what's called the BizSpark program. And included as part of the BizSpark program is a number of hours as well that you can use. And so that's another way that you can start taking advantage of Azure for free. If you want to use resources on top of that, you can pay for it. But there's enough hours included both for MSDN as well as for BizSpark that we think for most dev test environments for building apps and deploying them, there's enough free hours included that you can take advantage of. So anyway, we're pretty excited with Azure. You're going to see a lot more coming in the months ahead. And I think we have time for maybe 3 questions. We have about 5 minutes left. Any questions I can answer right now about it? Yeah. Good question. Yeah. So the question is about blob storage pricing, and so the question is sort of, let's say for example you're doing a blog, and how much would it cost to basically host your images for say your public blog using blob storage? And so basically the way blob storage works, I kind of mentioned here, if you can go to the more advanced pricing calculator, you can see kind of the different options. You basically pay by gigabyte, and then you pay by what's called storage transactions. And I think by storage transactions, it's, let's say you have 20 million requests per month. You'd pay, in euros, that would be 14 euros for those storage transactions. And it scales, so if you have 1 billion requests per month, the price goes down per transaction. And then basically you pay by the amount you store. And so for example, let's say, this is sort of designed for a lot of storage, so if you want like petabytes, but I think it's about 12, or it's 14 US cents per gigabyte for the first terabyte of storage, for 100 terabytes of storage. So it's probably around 9 or 8 euros per gigabyte. So if you're on a blob and you want to upload images, and you have, let's say, 1 million requests per month, you're probably paying 2 or 3 euros, it would be my guess, in terms of kind of the base storage and transaction costs. If you're publicly exposing those images, so in other words, someone's retrieving them outside the Azure data center, you will also pay network transaction costs. But basically, you can use the pricing calculator to kind of price it all out. And generally what I think you'll find is it ends up being pretty cost effective and in terms of total price. And again, the beauty is you pay for the what you use. So so the question is sort of how do you understand what you're using? So one other thing you can do is if you go to the website and once you've signed up, is once you sign up and log in, there's an account tab. And so one thing that we do expose through the account tab now, which is kind of new that we didn't do until December, is basically for each of the subscriptions that you have, you can actually see what your bill is in kind of real time. So we update this multiple times during the day. And you can actually see what are you actually spending the money on a per kind of item basis. And so if you want to see exactly how much data has been transferred in, how much has been transferred out, from what zone, what number of roles you're using and things like that, you can basically get kind of a detailed pricing. So generally what I recommend people do, and we'll also show you throughout the trial how much usage you've had. And so one thing you can do is you can actually sign up for the trial, try putting some code in there, run it for a day or two, see how much it would have cost you. And part of the reason for the account tab is now you have full control over kind of visibility into what you're spending. We also have, as part of the account tab, you can download the payment information in a comma separated version format, so you can import it into Excel if you want to do kind of more advanced modeling as well. So another question. Yeah.
Any plans to get a reseller account for Asia? So will I give all the services to our customers under our name?
Good question. Yes. The question is there an opportunity to provide like a reseller account for Azure? So let's say you're a solution integrator or a solution provider. Can you offer services to customers in your name and then use Azure? The answer is yes. You can absolutely sign up for Azure and then effectively provide your own services to customers, any number of customers using your Azure account. And so a lot of the, let's say maybe at least half of the customers we have today with Azure are typically ISVs or solution integrators. that are providing applications for other people. And so the beauty is you can absolutely do that type of aggregation if you want to. Cool. Well, I want to thank everyone for coming here this morning. I have another talk this afternoon on NBC4, which is a brand new talk that I will be doing for the very first time. We're pretty excited about it. And then tomorrow morning I also have a unplugged session. So if you have other questions about this, NBC, or any other topic, I'll also be available tomorrow for an open Q&A. So thanks a bunch and enjoy Tech Days.